Alright, so we're going to continue solving using elimination. But we need to make sure that we see a few that are work that don't have the same or opposite coefficients. And so make sure we're kind of in that boat. So if you're going to take notes, you can copy this down as I'm writing it. If you're choosing not to take notes, that's fine, but you need to be quiet and pay attention anyway.
No, we don't.
Okay. The problem on the board says 3m plus 4n equals negative 13, and 5m plus 6n equals negative 19. Alright, so listen up. If we're solving using elimination, we're trying to make sure that there is one of the variables has opposite coefficients. So again, opposite coefficients means that the numbers are the same, but the signs are different. Okay? I do not have that on either one of these two. On the M, there's a 3 and a 5, and on the N, there's a 4 and a 6. Okay? So we talked a little bit about how when you don't have the same coefficients or opposites, then you need to be multiplying the equations by some numbers. And the easiest way to go about that is to choose one of your variables, and it doesn't matter which one. Let's go with M, and that'll be the one we're going to choose to eliminate. So if I'm going to eliminate the M, what I need to do is I need to get these two numbers to be the same. Okay? And the best way to do that is just multiply them by each other. So what we will end up doing is multiplying the top equation by 5, because that's what's here. And what is the bottom equation we multiply by?
-3.
Yeah, it'll end up being -3 because we do want them to have opposite signs. So the 3 is definitely the case, but we wanted to make it a negative so that it's opposite of the top. Okay? So I'm going to rewrite these by distributing the 3 or the 5 and the -3. And we'll rewrite them over to the side. Okay. Hey, y'all, there's a lot of little conversations. So 5 times 3m is 15m. 5 times 4n is 20n. And 5 times -13 is -65. Okay, hey, y'all, the other conversations have to stop. Watching the video yesterday of this class period, I had to say that quite a few times for this class. So a lot of you are doing very, very well and paying attention and being quiet, but there's a chunk of you that are not regularly in here. There. Second equation, -3 is being distributed. So -3 times 5m is -15m. -3 times 6n is -18n. And then -3 times 19 will be 57. Okay, and you will use your calculators for those, that's fine. It's negative times a negative, so that last one will be positive. Without the calculator, in my head, I did 3 times 20 was 60 and then subtracted 3. Because it's 19 instead of 20. And so that's how I got 57. Alright, next, now we have opposite coefficients on the M. And so we're just going to add our two equations together, and that's going to eliminate the M. So 15m minus 15m is 0. 20n minus 18n is 2n. And then negative 65 plus 57
-8.
is negative 8. Okay. And so to continue that, to get n, we divide both sides by 2. So n equals negative 4. Hey, be quiet, please. Okay. So, similar to yesterday, once you find one variable, you're not done yet. You got to go back and find the other one. So I need to plug the negative 4 back in for one of the two equations for n. So I just use the top one. So that's 3m plus 4 times negative 4 equals negative 13. So at this point, the only thing I've done is replace the n in that first equation with the negative 4. And then I'm just going to evaluate pieces and solve for m. So I'll start out by multiplying 4 times negative 4, which is negative 16. So I got 3m minus 16 equals negative 13. Add the 16 to both sides. So 3m now equals 3. So lastly, divide both sides by 3, so m equals 1. So what is my solution? 1 negative 4. In parentheses. Over the last day or so, looking at some of the work, I see a lot of people that will write the 1 negative 4 side by side with a comma. But you gotta have the parentheses around it, because that ordered pair always has the parentheses. So make sure that that's the original. Questions? We're going to do one more example, and then I'll turn you loose on the assignment. Actually, 2 more examples. Sorry, there's 2 things I need to show you. All right, first one looks something like this. When you're still asked to solve using elimination, but your equations are not in an order that you're used to seeing. So, this would be positive 6. Okay. So if you're choosing which method to use on this problem, I would choose substitution because y is already solved for in the first equation. But the problem's asking you to solve using elimination. So to do that, the first thing you have to do is you need to get the x's and y's lined up. Okay? Which means I need to move this x over here. So this minus x from the 4 needs to come to this other side. So to do that, I'm going to add x to both sides. I'm just going to rewrite that down here. That becomes a positive x plus y equals 4. So all I did on that first equation was move the x from the right side to the left side by adding it to both sides. Yes. To use elimination, I need to make sure all my x's and my y's line up. But that first equation, this x is on the far right. So I need to move it over here so that it'll line up with this 3x. And so to do that, since it was a minus x, I added the x. And so that's down here in red. I moved the x out to the front so it lines up with the 3x. the positive y is this plus y, and then that 4 is still left there. So at this point, this is a pretty simple elimination problem once you get the x to that side. What you need to do, though, is multiply that bottom equation, or the top one, either one, by -1, so that your y's will be opposites. Okay, so I'm going to rewrite the 3x plus y equals 6. And then on the negative, I'm just going to change the sign on all of the bottom numbers. So -1 times x is -x. -1 times y is a -y. -1 times 4 is a -4. So this one's set up a little bit differently at the beginning. Once you get them lined up, it's not a real difficult problem. Okay, at that point, we can just add. So 3x plus a -x, or 3x minus x is 2x. The y's cancel out, and then 6 minus 4 is 2. So divide both sides by 2, you get x equals 1. In just a second, you'll be able to. I'm almost done. Well, I need to do one more quick example, but you need to be able to see it. Okay, I'm going to go back to this first equation and plug that with x in. So y equals 4 minus 1. So y equals 3. My solution is 1/3. Okay. So even with it being one where you had to move stuff around, there wasn't very many steps involved anyway. Okay. But you got to make sure that your x's and your y's line up before you can use elimination. All right. Okay, questions? All right. All right, last example. Okay. Let's talk through this one real quickly. Do I have opposite coefficients on any variable? Yes. Which one? I just have it on both, the x and the y. Okay? So on this problem, and this is going to turn into a really quick problem, what happens when you add 2x and a -2x? Cancels out. That's 0. What happens when you add -3y and positive 3y? Cancels out. Everything cancels out, so the left side is equal to 0. Okay? On the right side, you have a 6 and a 3. It's 9. Yeah. When does 0 equal 9? Never, so there is no solution. So if you end up eliminating both variables, listen, if you end up eliminating both variables and this side does not equal 0, then it's no solution. If you eliminate both variables and this side equals 0, then it's all real numbers, all solutions. It's infinite number of solutions. Okay? All right, so that's the last example there. All right, so go up here and choose this. All right, so your assignment is these problems 9 through 26. Okay. Says they're due on Thursday. You may need to come up here and copy stuff down.